wherever you go. Sweet and low, more people you know. Sweet and low.
It's part of my life.
Saccharin is commonly known as the trailblazer of artificial sweeteners. During the sugar shortage of World War I, saccharin became increasingly popular, but was not yet widespread. It has been branded and marketed as Sweet and Low since 1957. By 1960, Sweet and Low could be found in almost every household. Saccharin was discovered accidentally. It is popularly known as Sweet and Low, which is mixed with aspartate to increase shelf life. It is 300 to 400 times sweeter than sugar. It is considered to have 0 calories since it does not get broken down in the body. It is also safer for those with diabetes. Unlike sugar, it does not spike blood glucose concentration.
Konstantin Fallberg, a chemist at Johns Hopkins University, accidentally stumbled upon saccharin as a sweetener while working with coal tar in Ira Remsen's lab. He was taken aback by the sweet taste on his hand one evening, and connected this compound with benzoic sulfamide, on which he'd been working that day.
After discovering saccharin, Konstantin Fallberg left Remsen's lab and began patenting the product in different countries. Fallberg started manufacturing the substance in a factory in Germany and grew very wealthy.
On the matter, Remsen commented, "Fallberg is a scoundrel. It nauseates me to hear my name mentioned in the same breath with him." He was left irritated as Fallberg stole what Remsen perceived to be their combined efforts as his own when he left to Germany. Let's do a quick overview of how Fallberg synthesized saccharin. He used toluene as his starting material, which went through sulfonation. Because of the methyl group of toluene, he ended up with an ortho and para product. The ortho isomer is separated, then converted to sulfonamide with ammonium, which leads us to our last step, an oxidation to form saccharin. Let's take a closer look to these reactions. Before we start, we have to prep the reactant. The oxygen attacks the sulfur, which forms an intermediate. The electrons on the oxygen move down, kicking the chlorine off. Now the reactant is ready. Toluene attacks the sulfur, which causes another intermediate. The electrons on the oxygen move back down, and now the other oxygen is kicked off. This leaves us with sulfuric acid as well as the ortho and para isomers. In this case, we're just going to focus on the ortho isomer. Ammonia then acts as a nucleophile, attaching itself to the sulfonyl chloride, leading to yet another intermediate. The oxygen's electrons move back down, kicking the chlorine off, which then takes the hydrogen, making hydrochloric acid, and our second to last product. Hey, are you still with me? Good, because the last step is the oxidation, which leads to our final product, saccharin.
Saccharin in the synthesized form is not water-soluble. In order for it to be used as a sweetener for food and beverages, the sodium salt form of saccharin is used.
It isn't entirely known why saccharin is sweet. Studies have shown that if the structure of saccharin is slightly modified by changing the hydrogen on the amine to a methyl group, it is no longer sweet. It is a hydrogen that is thought to interact and fit perfectly with taste receptors.
When Roosevelt was approached with a proposal for banning saccharin, he said, "Anyone that says saccharin is injurious to health is an idiot." As saccharin became widespread, it became the subject of much controversy as more studies were analyzing its effects. A study on rats where rats were being fed high concentrations of the substance found that rats developed bladder cancer. A ban on this product for use in processed foods was attempted by the FDA but was short-lived because studies on other animals did not show the same results, proving the results of the initial study inconclusive.
Sweet and Low has been helping millions of people cut calories. People who want to get more out of life.
Wow, what a cake! Sweet and Low? I've been baking with it for years.
Get more out of living, you and Sweet and Low. Wherever you go, Sweet and Low. Wherever you go,
for watching!